that's the second exercise. So it's still using a superposition theorem. So we always do that in 3 steps. So in the first step you are going to consider this source of voltage, and then you are going to close that one. So we are going to say, so that is step 1. So we are going to close the 60 volt source of voltage. And here we are going to consider so we are going to close 60, and then we are going to consider 40. So if I represent the actual diagram would be so we have 40 volts here, then we have this resistance which is 5 ohm, and then here we have 10 ohm, so we have the line currents here flowing in 15 ohm. So they want us to determine these currents here. And then here we have 8 ohm. So because we just closed this voltage, so there's nothing there. So we only have a resistance of 12 ohm in this branch. So you also have and we have 10 ohm here. So now we are going to work this out considering only this voltage source. So we realize that, so how to find we first need to determine the total current. So we are going to call that I total. We are going to call this I total 1 since we are in step 1, but in step 2 we are going to call it I total 2. So here we can see that these two resistors are in series, so they can be replaced by one equivalent resistance. Okay, I'll try to highlight it. So if I have these two this resistance here, they are in series, so I can replace these two by a single resistance. Since they are in series, we know that the equivalent resistance will be the sum of these two. So now all these sets will be in parallel with other two resistors. So in other words, this one and that one as well as that one, they are now in parallel. So we are going to have three resistors that are in parallel. So I'm gonna have a single resistance here. So now we are going to we can replace all this by one single resistance. So now that single resistance will be in series with that one as well as that one, as you can see here. So all I need to do first is I first need to determine the equivalent resistance of these two. I get one resistance, and then I'm gonna need to find the equivalent resistance of these three, because I know that they are in parallel, so I can get one resistance. So now this resistance will also be in series with this two, so I can get the equivalent resistance of the entire circuit. So it's gonna be the total of that one plus that one plus that one plus that one. So I'll first work out the equivalent resistance of the all sets here. So we can write down immediately the expression of the equivalent resistance. So the equivalent resistance is equal to, because I can see that these three resistances are in series, so I have that one, and that one. They are in series. Since they are in series, so we are going to have when I have to add the resistance, so I'm going to have 5 plus 10 plus. So now I need to write the expression of the whole thing here, so I'll just put it in brackets. So I have that one plus that one plus that one. So this all parentheses represent this one. So I use the sign plus because the resistance are in series. So when the resistance are in series, always add them. So now I go inside this block here. Inside this block here, I can see that this resistance is in parallel with this resistance, this resistor, and it is also in parallel with this one here. So that is a block which is inside the red block. So since they are in parallel, I'm gonna write the expression of write down the expression of calculating the equivalent resistance when the resistors are in parallel. So here I have the value here, which is 15. So 15, I'm gonna say 15 is in parallel with that one, which is 15 is in parallel with 8, and then at the same time is in parallel with the yellow block. So I'll just include it there. So what I can do, I will just replace the yellow block by another color so that it's very visible. So now we need to put value inside here. So the equivalent resistance of the green block will be the sum of these two, since they are in series. So I'm going to say the equivalent resistance will be 10 plus 12. So then I'm gonna need to simplify this until I get the final answer. So the final answer here will be the equivalent resistance. So I can see that I can add these two. So that gives 5 plus 10 gives 15, and then I say 15 plus, I have 15 which is in parallel with 8 at the same time, which is in parallel with these two. It is in parallel with the green block. So the value of the green block is the equivalent resistance of these two, which is equal to 22. So from this step, I will first work out the parentheses. So I'm gonna have 15 plus. So to find the equivalent resistance of these three values, so the equivalent resistance will be equal to 1 over 15 plus 1 over 8 plus 1 over 22, and then the inverse. So I need to find the inverse of 1 over 15 plus 1 over 8 plus 1 over 22. So that can also be applied when we have two resistors that are in parallel. So when we have two resistors that are in parallel, the equivalent resistance will be the inverse of 1 over the first resistance plus 1 over the second resistance. So same thing if we have many resistors like here. So we have 15, 8 and 22 which are in parallel. So to find the equivalent resistance, we are going to say 1 over 15 plus 1 over 8 plus 1 over 22, and then the inverse. So that gives 15 plus, so we're going to first work out the bracket. So we're still doing step 1. So we have already determined the value of the total current. So now we are gonna need to find the current in 15 ohm. So that current is split into 2 branches. So we have the first branch and the second branch. So we have another current going that side. So to find the line current in 15 ohm, so I'm going to use the same principle. So we first copy the total current, and then we multiply by the sum of the resistance. So here we are going to consider, since we have 2 branches, so we have the first branch. So the second branch will be all this. So in other words, I'm gonna need to add these 2 resistance at the bottom. So I have the first resistance, which is 15, and then I say plus. So the second resistance will be the equivalent resistance of all these 3. But since I can say that these 2 resistances are in series, I can say that these 2 resistances are in series. So in other words, these 2 will now be in parallel. So I need to find the equivalent of this one and that one. So I have my red parts here, which is made of 8, which is in parallel with these 2 resistance. So which is in parallel with the green box. So in the green box I have 2 resistance that are in series. So the 2 resistance are 10, since they are in series, so I'm gonna add a plus. So we have 10 plus 12. So now, since we are calculating the resistance in 15 ohm, so I'm gonna use the opposite of the resistance, which is in parallel with 15. So in other words, I need to put this on top. So the equivalent resistance of this is the same as that one, what I have in the red box. So I'll just copy all this and then put it on top. So I'm gonna have 8, which is in parallel with 10 plus 12, and then which is in parallel, and then we close the bracket. So if I simplify here, I'm gonna get 2.08146 multiplied by 8, which is in parallel with, so that is equivalent to 22. So I'm gonna replace this by 22, and then at the bottom I'm gonna have 15 plus So same thing, I'm gonna have 8, which is in parallel with 22. So now I'm gonna need to find the expression of this and this one, so which are basically the same. So I'm gonna have IL1, which is equal to, so I'm gonna copy the total current and then I multiply by, so the equivalent of this is equal to 1 divided by 8 plus 1 divided by 22, and then the inverse. Same thing here, so I'll first copy that 15, so we can also replace 8 parallel 22 with the same expression. So we have 1 over 8 plus 1 over 22 and then the inverse. So now we just need to compute the whole thing to get the line current in 15 ohm resistor. So if you compute the whole things, we get 0.58520 amp. So how did I get this one? So we can also work out the part separately. So it means that you first work out this, you get a number. You also work out the denominator, you get a number. So and then at the end you multiply and then you divide. So now we just complete the first step. So now let's go to step 2. So in step 2 we are going to consider this source and then we are going to close that one. So if we redraw the entire circuit with 40 volts, which is short circuited, so we're going to have, so we won't have any voltage here because we just close 40 volts. So we'll now consider that source. So I have 5 ohm, so you also have a resistor here, so the value is 10 ohm. So we have 15 ohm, 8 ohm, and so we have 10 ohm as well as 12 ohm. So the value of the source of voltage is 60. So we are only considering this voltage. So then here we have the total current, and that is called IT. It's symbolized by IT. So we also have the line current in 15 ohm resistor. So we are going to do the same procedure, as we did in step 1. So the first thing to do is to determine the total current, and once I have the total current, since I know that there is one part of current that's split in 2 branches, I have the first branch and then I have the second branch. So since I'm gonna need to find these currents here, I'm gonna use that branch. If I know the current in this branch, I can easily determine that current, since the main currents here will be split into two branches. So I have the first branch and the second branch. So I will consider the currents in this branch. So how to determine the total current? So to determine the total current, we use the same formula. So we have the total voltage. So I'm going to say IT. So that is 2, since we are calculating, since we are in the second step. So we need to use the total voltage divided by the equivalent resistance. So the equivalent resistance will be, so here we can see that we have 3 resistors that are in series. So we have the first resistance, the second resistance, and the third resistance. So as I can see here, all these 3 are in series, but this resistance is a block of different resistors. So we have, if we go inside this block, we are going to say that we have this resistance, this resistor, which is in parallel with that one. Okay, this block is fine, but I can also go inside this block here. So I can say that there is, we have some resistance that are, we have 2 resistors that are in parallel. So I have the first resistance, which is in parallel with that one. So I can also go inside this block, because in this block there are 2 resistors that are in series. So we have 5 and 10 ohm. So now I need to write the equivalent resistance. So the equivalent resistance will be, I first consider, so I'm gonna add the red block, since they are in series. Because they are in series, so we are going to have 12 plus, we have 10 here, and then we have this resistor here. So I'm gonna say plus so this bracket represents the entire block. So if I go inside the bracket, I'm gonna consider first the green color. I will first consider the green color, because these resistance are in parallel. So that means we have So we have 8 ohm, which is in parallel with the green block here. So inside the green, I'll first copy the green block, and then I'm gonna put the expression that are inside. If I go inside this green block, I can see that we have 5 ohm, which is also in parallel with these 2. So I'm gonna say we have 5 which is in parallel with, so these two are in series. So since they are in series, the equivalent resistance will be the sum. So we have 5 plus 10. So now I need to compute this expression. So I'll first simplify it. So I have 12 plus 10, I get 22. 22, I say plus. So I'll first be concerned to calculate the value that are separated by a plus sign, like here. I can replace all this by 1. So I have 8 parallel, which is in parallel with 5, and then in parallel with, so here I have 5 plus 10, so I get 15, and then I close the bracket. So now I'm gonna have 22 plus 8, which is, I will first compute I'll first compute the expression, the values which are in the inner bracket. We have the inner bracket, which is that one. So I'll first compute this. So 5 parallel with 15 is equal to 5. So that gives, so if I compute these parts here, I have 1 over 5 plus 1 over 15, and then I use the inverse. So I'll end up with 22 plus 8, so I can replace all this by 1 resistance. So the equivalent resistance of all this, if you use the calculator, you can get 3.75. So now I realize that these two are in parallel, so I can use the same. I can also use the same formula. So I'm gonna have. So if I continue, I'm gonna have 22 plus 1 over 8 plus 1 over 3.75, and then the inverse. So this is the expression of that. So finally I get the equivalent resistance, which is equal to so I end up with 2.4437 amp. So that is the total current. But since I'm concerning to find IL, I won't use that total current, but I won't say that is the current IL, because that IL is the derived current of the total current. So now we're gonna need to determine the current that derived from the total. So we have the main current, which splits into two currents. So we have that current and that one, but we will be concerned to find this one. So I'm gonna maybe call that I'm gonna call it I. So I will just call it I. So now we are going to use the current divisor theorem. So to find I represent that current. We are going to copy I total and then we multiply by. So we have the phase resistance here, because we're gonna need to to add this to the green resistance at the bottom. So we have 8. So we have already determined the equivalent resistance of that block here, the green block. Because here I can see that we have two resistances that are in parallel. So we have this one and this block, they are in parallel. So the resistance, or the equivalent resistance of this block is 15. So 15 is in parallel with 5. So 15. So if I say the equivalent, if I need to find the equivalent of 15 and 5, I'm gonna use, I'm gonna say it's gonna be the inverse of 1 over 15 plus 1 over 5. Work this out already in the previous slides, so yet 3.75. So now on top I'm gonna, because as I'm calculating the current that is entering in this box here, so I'm gonna need to use the opposite box, the box which is opposite to that one, so which is this one here. So the value here is 8 ohm, so I'm gonna put 8 on top. So now I'm gonna determine the value of I'm gonna determine the value of I. So I'm gonna say I is equal to, so if I use the calculator to compute this, I'm gonna get, so the value is equal to 1.6665 amp. So that is not the line currents here, because I can see that that I also splits into two parts. So we have the first part and the second part. So the I splits into two currents as well. So we have the first current and the second current, which is IL. So now I will be my total current in order to determine IL, so the line current. So what I'm gonna do here is I'm gonna use the same logic. I'm gonna consider that I to be like my total current, and then I'm gonna multiply by, so we have, if we look at the current inside the green box, we have these two resistors. So I'm gonna add these two resistors. I'm gonna add these two resistance. So I'm gonna have 5 plus 15, because these two resistors are in series. So I can replace it by one resistance of 15 ohm. Since I'm calculating, since I want to compute the current flowing in 5 ohm, so I'm gonna consider the resistor which is opposite to that one. So in other words, I'm gonna consider this block. So this block, the value of this block here is 15. So I'm gonna put 15 on top in order to get, so that's gonna be the load current 2. I mean the line current 2. So I call that line current 2 because we are in step 2. So step 2 says short circuiting the 40 volt source and considering the 60 volt source only. So we are going to call that the second line current. So if I compute the whole expression, I'm gonna get, so in fact the value of that resistance is 15, so it is not 5, so I need to have 15 here. Okay, let me just double check if so the same mistake was reproducing this step as well. So here we need to have 15 instead of 5, same thing here. So that value here is 15, not 5. So I need to have 15 here, and that is a 5 that I can see there. So that's supposed to be 15, and that's supposed to be 15 as well. And what else? So this part here will change, so I'll just reproduce this part again. So I just replace this, and then I've determined the value of I. So I, which is this current here. So now this current will split into 2 branches. So to get IL2, I'm gonna consider that I to be the total current of these 2. So I'm gonna copy it here, and then I multiply by the sum of the resistance. So we have these 2 resistance which are in parallel. So we have that one is 15, and that one is also 15. So I'm gonna have 15 plus 15 at the bottom, and then on top I'm gonna use the value of the block which is opposite to the one in which we want to determine the current. So we are going to consider that block and then put it on top. So the value of the equivalent resistance for that block is 15. So now we are going to compute the whole expression. So we are going to get .78951 amp. So that is the line current in this resistance. So now we are going to do step 3. So in step 3 we'll just add the line current that we have found in step 1 and the line current that we have found in step 2. So another problem in step 2. So that resistance here is not 3.75. This one is not 3.75. It's equal to 7.5 instead of 3.75, because we can see that these 2 are in parallel. So we have 15 which is in parallel with another 15. So that 15 is the result of 5 and 10, since these 2 resistors are in series. So therefore we have the resistance of 15 which is in parallel with another resistance of 15. So to get the equivalent resistance here, so I can say that that value is equal to the inverse of 1 over 15 that one here plus 1 over that 15 here, and then the inverse since they are in parallel. So if you work this out, you are going to get 7.5, not 3.5. So we just replace this value by 7.5, and then we carry on. So that's gonna affect the value of I2. It's gonna affect the value of I. So I will then be equal to 1.197. So that is the value of I here. So now to find I2, we'll just replace that I there. So we're going to use the same logic. So the value of I is equal to 1.197. So if we need to multiply by this, we need to multiply by the sum of these two resistance. So this resistance came from the green block, so we have 15 and 15, and on top we have another 15 because we are calculating the current in IL2, the line currents here, so we're going to use that resistance on top, so we have 15 there. But in that case, all these two resistance have the same value, so that will change to so if I say multiply by 15 and then I divide by 15 plus 15, this is equal to 30. So I end up with 0.5985 amp. So that's 7.5 is it. So there is the result of this procedure. So that is IL2, the line current in 15 ohm. So now I have IL1 and IL2, then I can determine the total current. So the total current will be the sum of the line current, the total line current will be the sum of the line current found in step 1 plus the line current found in step 2. So that's gonna be equal to, so I have the line current in step 2, which is 0.5985. So now I need to, so here I'm gonna have the line current found in step 1. So the value is so the value of the line current determined in step 1 is 0.5852. So that represents IL1 and that is IL2. So if I add these two currents, I'm gonna get so we have 8 here if I add these two, I'm gonna get so I get approximately 1.1837, so which is close to 1.184 amp. So it's close to the answer that is found in the book.